Hey, hi, Marcus. How are you doing?
Yeah, I'm good. It's great to seeing you and great to share my work in DSPy as a whole. Because I've used the programming for such a long time, and it's awesome to speak to someone that's also used it.
Awesome. So, hi, everyone. My name's Ankur. Welcome to the podcast. I stumbled upon Marcus's repository on Tree of Thought implementation, and then we connected over Twitter and exchanged a bunch of messages. And I thought it will make up for a great podcast for people who do know what is chain of thought, but have no clue what Tree of Thought is and what it led to. So, Marcus, welcome to the show. Would love to get an introduction from you, what you're doing.
My name is Marcus. I'm from Åland Islands. It is a small island in middle Baltic Sea between Sweden and Finland.
Okay.
Finland is about there, and Sweden is there. There's a small
Okay.
island in Baltic Sea called
Oh,
Åland
wow.
Islands, where I'm from.
Okay.
It's not Finland, but my mother tongue is Swedish because the island in itself
Okay.
is Swedish speaking.
Okay. Got it.
Um, my skill set is actually from I have a bachelor's degree in political science, and then went over to finance for a master's degree, and then at some point I picked up coding and learning Python coding especially, and then from there also picked up the skills in Go and in a little bit of C++ here and there for some specific financial use cases, and
Okay.
then I stumbled into the AI space where I learned from going from line chain to crew AI when building agents to even at the moment into DSPy, because DSPy does everything in the most optimal way. And that's also a project I've decided to fine tune my skill set.
Well, thanks for the introduction and sort of walking us through your journey. Yeah, you rightly said. I think DSPy just gives you a lot of granular control over what you want to do once you learn the framework. And I think that's what most of the people enjoy. So, Marcus, let's talk about the subject of our podcast, which is tree of thought. And chain of thought is essentially asking the model to reason as it arrives to its answer. What exactly is tree of thought, and how does it extend chain of thought? Over to you.
Yeah, I would explain this in probably the most rudimentary way possible, because I see you can solve LLM types problems in different ways. You can solve it either by throwing computer the problem. That's just the most simple brute force way of solving a problem. You take the LLM and then you give it a prompt in the chatbot interface, and you just go mash as much compute as possible to it. That's just the complete simple way of doing it. When you add reasoning, the reasoning capabilities come from chain of thought, where you think you go into a labyrinth. You have this massive labyrinth,
Right.
and you can do on the first reasoning chain. You go to, oh, here's my first step. Where do I go now? Oh, there's an opening. I go there, and then okay, reasonably speaking, I should pick right now. As I picked left on okay, I go right, and then I go through them in a step-by-step function until I come to the end.
Okay.
This doesn't necessarily share as the best way of solving the problem, because in many cases we also judge it by its output. When you judge something by its output, you also come to the conclusion that is this really the best answer you can actually come to.
Got
Tree of
it.
thought
So
extract
basically, there are multiple. Go ahead.
multiple choice. So you can think of it as multiple choice, but that's just the rudimentary way of explaining it. When it comes to tree of thought, you actually extend this with decision trees. And decision trees is actually just you have one answer, and then you have three answers, and you have five answers, and you have seven answers. And in
Right.
the labyrinth use case, you also go through this thought process by going through, oh, you have three open doorways, let's pick this one, and then you go through the next one, you have five more options based on the preconceived notion that you have based on your three different answers, and then you come to a conclusion probably more in a human form, where we take in much more context of coming to the conclusion with different search strategies that we can develop to solve this problem.
Okay. So basically, we find out multiple paths of reasoning as opposed to just one, right? So it's not a linear way of thinking. It's like
Exactly.
and you gradually keep going down. So as you're going in a tree of thought, do you sort of also keep evaluating the thoughts and prune certain sort of chain of thoughts and just remove them from the tree so that you focus on few, or is it just like a very deterministic sort of that you would pursue every tree of thought, every branch, so to speak, or is that implementation specific?
That isn't something I have thought of that in that type of way. That's a great thought experiment to work with further. Because my first thought of this whole project was to see, can we apply some type of tree of thought into DSPy? Because at current implementation of DSPy, there
Right,
isn't one.
there isn't.
What
There's some PRs
what
and
can we do? Yeah,
there's another repository by
how,
Stanford.
like how it essentially works. In that way, I saw a paper from, and their whole repo from, I believe it was Princeton NLP that had developed True Thought when they did this with GPT-4o, I think, if I remember correctly. And they have also started with, I think they also started with breadth first, and then also took some kind of consideration into that first. But I think mostly they back to breadth first at the moment.
Got it.
Or I think they show children cases that are extended with different search algorithm search models. So in that case, I just want to share different search models of solving trivial type style problems, and then denominated with K for how many decisions or how many thoughts we want to go through.
Got it.
So that's just
You have some
how I
output
decided.
for us which you want to share? Maybe,
Yeah,
you
of course.
can show that and sort of explain, probably be more intuitive.
Yeah. This is a very, very, very long case,
Okay,
and I've uploaded it to 50 GitHub at the moment.
sure.
And I will just push this as an example. Something what was quite interesting to me was when you apply the DSPy model agnostic system, you can also try this with different models.
Mm-hmm.
As the usual true thought experiments are done with GPT-4o, I was able to just run this with even with a Metalama model.
Okay,
So
understood.
super expensive or
Understood. Yeah, no, that works. I think for creative writing and these kind
it's
of
actually
things,
interesting in
yes.
itself.
Okay. I think for creative writing, a smaller language model should do just fine. And from what I understand, so correct me if I'm wrong, the way you're doing this is you're giving an end sentence and then asking it to sort of reverse track from there and come to that end sentence and get multiple options for that, right?
Yeah, but in this case, I also even asked it to throw in more and more data to it, and then see what would happen as the
Okay.
examples in my original GitHub was quite close to each other, so it didn't really make sense. So a little bit of an improvement, but then we came to more of a different bus passages as a whole.
Mhm.
So, and where it came to like, okay, this is how many steps it has taken. Oh, okay, we didn't really come to good conclusion. Okay, keep going, and then turns. And when we scroll down, we can also see uh, because we have different test cases of these 5 different
Mhm.
models, and then we have them right here.
Okay, so this is the overall summary.
And the summary of it essentially is we have breadth which explores different model options at each levels, and depth first, which explores deeply before backtracking. Beam first keeps up candidates, balances, and multicolored research, which is more balance and exploitation of options, and then best first doing the effective based on heuristics, and we
Understood.
also and summary right there.
Okay, so I've got a couple of questions for you on this. So, one thing, like you were using the Meta 3 point, 1 billion parameter. I'm not sure which one it was, but does it make sense to have two models in the implementation? One which is generating, the path for you. The other is the one which is evaluating it, right? For better quality. Like, what's your thought on that?
I mean, The problem there is that we also need to take into account for how two different models can be applied into the system, but also how to actually evaluate them and have one supervisor model on top of it and see if the cost breakdown of this is actually worth it. That's just one thing I'm directly thinking of. But in many cases it's probably still not worth it, because it will just be an implementation task and another tax worth of paying for all the model costs. But in generally speaking, I would probably say that
Okay.
it's probably still worth it to have two different models, because we have a more capable model on top of another. I also believe this is how OpenAI has then come to the conclusion of when building
Correct.
their newest model, is having a smaller model that does the reasoning chains, and then you have another model on top of it that says, this is actually good, we can take this into account for when we're building the next step in process.
So that was one aspect. By the way, personally, I've seen pairing a larger model to be the evaluator, especially when you have long plans, have generally been helpful. Now, and you mentioned a very important point, which was the cost aspect. So going with that sort of thought, uh, I mean, a tree of thought involves decent amount of token expenditure, right? With all the round tripping, etc. So, are there any sort of hacks that can be used, heuristics? Like how can one? So it's very clear that chain of thought won't do. You need a tree of thought, but you don't want it to be as expensive as the runs would be. So what can one do? Right? Like, what are your thoughts on
Yeah,
that?
how I see this, generally speaking, I would see this in a way where I see it as, okay, in my research, in my large research case that I'm going to do, I'm going to test different models, and when I run it, I first try the brute force way of just pushing compute at the problem with no chain of thought at all, just to push compute at the problem, and I'm not really happy with that result. So then I go to building a DSPy system, and I've added in chain of thought. And after this example, when I'm going through taking all information into place, and this model is great, and the example isn't really that great at all, and I'm not really happy with the result, I can then go to tree of thought and see if tree of thought actually come to the best conclusion. And then in
Got it.
that case, I can also test different free models, because those are still generally available and people can absolutely play around with them for many cases. And then can we also go through the different search models if we see that, oh, we have found that with different search algorithms we have found different better solutions, and then we can just pick one and then apply our cost-heavy model to that problem, and then we have come to a cheaper output in general, instead of testing with the best model at every case. Because if you test them the first cases with a local 8 billion parameter model, and we see that we actually, when we apply this problem to algorithmically to multi-colored research, we find the best answer. Oh, great! Now we know that too when we apply the GPT-4o model to this case,
Got
and we
it.
have actually found the right search for the problem.
So what I've understood, what you're saying is that you figure out the domain, your use case, run a bunch of tests and see how it's performing, and then sort of decide which model to take, right? So basically spend a lot of time with data output before you to make a better choice. Is that the right way to?
Yeah, definitely, because we can also just think about it like in a sense of like, oh, we have a math puzzle, then we know we need the best first model, or a crossword puzzle, we know that we need the depth first model.
Mhm.
Same thing. Then we kind of might go to blog writing. Then we might need to, oh, we find the best solution for that is probably a beam search model. We can then just also pick which one we need to apply. But in many cases where we come to the conclusion that, oh wait, we need to solve this large business case, many of these are still a big part of it. It can be
Right.
both strategic planning, and it can also be legal drafting. Both of these two cases are either we need to, in one use case, we need depth breadth first, in another case, we need depth first. This
Got
means we need to find which model actually performs the best, and in that case, we need to run those tests, because otherwise we don't know. We know that in part A of our problem, we need one tree of thought, and another part we need another part of tree of thought. So do we run them separately and then combine the answer in together, which we're happy with, or do we combine them with a better type of search strategy, which might be if I come to the conclusion that it's multicolored tree search, or if it's, for example, the first. We don't know before we start doing the testing within itself.
Got it. Spend time with data, do a bunch of experiments, learn from it. Awesome. So
Yeah, I think
I've got my
how
final question
do
for
that.
you. Sorry, you're saying something.
Yeah, I in many cases, because as we've seen the whole paradox of 4 months ago, people were saying you can't just throw a computer at the problem. I don't really know if that actually is the case, because we saw with Grok and Elon Musk where they essentially just built up this giant factory and they essentially just threw computer at the problem and the model became better.
Yeah.
We also see this similar with the release of Gemini 3, where they have a bunch of NVIDIA GPUs for model training, and then on their inference side they have the TPUs. I don't know if that is completely true, as someone is speculating that they maybe only using TPUs for it, but in many cases it is probably still using a lot of NVIDIA GPUs, and then they have their TPUs stacked for inference. And in this case, they have essentially just thrown compute at the problem, and it's still getting better and better results. And the same thing goes for OpenAI. They're also done a similar thing where they have just expanded by building more and more into NVIDIA compute. So they have also just thrown compute at the problem. So that brute force ways still seem to be working in many, many, many cases. So that's why I'm also leaning towards needing to test different models, different model outputs until we come to the conclusion that we actually are happy with.
Yeah, there's a saying, right? Brute force always works. Okay, so I've got a last question for you. So you have coded in LangChain, you have now coded in DSPy. And so how has your DSPy experience been, and what is it that you like the most about the frame?
I actually think it is the modularity, because when I started with LangChain, I needed to write this whole English essay. It was this long English essay of like 4 pages of like English, of like, did I spell this word right? Did I spell this right word? I can't be asked. And this thing is just annoying. I have my data, I have my question, and I want the model to figure it out. And that problem of like building this large prompt and then have that file in, you need to say, hey, I want you to use this file for my whole prompt. I felt that was just annoying. And that didn't really work for my brain. I wanted to actually have a modularity of, oh, this is the signature. I want you to think this way. This is my output signature. I want you to get me the output this way. Great. And I want you to combine it in this way. And this is the module I want you to use. And that modularity just worked excellently on how I'm built, because then can I just ask a question. Even building in CLI applications, I can just ask a question. Okay, great, that's the answer. It runs through the Postgres database and it outputs an answer. I'm happy. And similarly, when building agents and agent frameworks, I would also tend to lean this way of using LangGraph as the orchestrator, MLflow to evaluate everything, and DSPy as the core agent framework. Because when building with True AI or Agno AI, both of the systems are fantastic. They are really, really good, but they are not as modern, and all their tools are built as let's push this project out as fast as possible, because that is really good.
That's
just
universal.
have this problem. It's awesome because you can just have this Python class and all the tools are Python functions, and that works. But you don't really know if the output is optimal, or if that output can then be used as a plan to make strategic business decisions. And in that case, is DSPy better? DSPy I can just modularly, I can point out, oh, I need this to be 5 sentences long. I need it to be
very easy to extend and maintain.
400 tokens.
Yeah.
I can change code in everywhere, and then I have just the perfect answer. And that's something I really liked, because it felt like I was building a system more so than just this simple sketch of what is actually happening. I can actually, this is a system, I want it to output in this way, and I want it to actually make something that I can take with me, show my boss, oh, this is my conclusion. It's like,
Got it.
oh wait, this is actually awesome. I'm happy with it. That's just different approaches on how to build large language models.
Got it. Awesome. So, Marcus, thanks for your time and joining us from your lovely place. I think we are wiser today after having this good conversation with you. And thanks for being on the show.
Thanks so much for your time. I would also like to share my GitHub with my project of what I've
Sure.
done. Here's actually my GitHub, and it is github.com/Marcus Yihansson, and both built in refract system for DSPy for optimizing large language models for on write tasks, which was actually massively successful because it actually made RAG much cheaper, and also play around with an MCP style tool type of system where you can build your own tools and attach them to the process, and then just use a CLI application of saying, hey, I want this. I want financial data for Apple, or I want stock data for Apple, etc., etc. And then this whole DSPy tree of thought style problem. So these are like some of my test cases of like, oh, let's see, because you can actually just build things, which is a really awesome thing. From the conclusion of you can just build things, and especially with AI tools and with how modular, especially UI is, it's actually awesome, quite awesome to build with. Thank you for the time, taking the time to have this conversation with me and have this whole time that we had before this with technical issues and so on and so forth. And I'm just happy to have this conversation.
Same here, Marcus. Thanks for doing this.